Hello, everybody, and welcome to the African EV podcast, where we talk about sustainable energy and transport for Africa. In this session, we are going to be talking about electric vehicles for long haul trips, for construction and mining. And our special guest today is Antti.
Hello.
How are you?
Nice to be here.
Oh, Antti Jalomaki. I hope
I'm
pronounced it. I'm doing very well. How about yourself?
Yes.
So, Antti, can you tell us a bit about yourself and how you got into the whole EV space?
So, I'm originally from Finland and from country farm. We used to have cows and chickens and horses and tractors, and that's why I'm really familiar with all the farming equipment and all the heavy stuff. And I worked as a excavator mechanic during my studies, and also an excavator driver. And I repaired heavy trucks and passenger cars and everything, like dump trucks and wheel loaders and everything. So I have a lot of hands-on experience on that. And when I was studying mechanical engineering on university, I fell in love with energy efficiency when I started racing in the local eco marathon team. We built and designed our own fuel economy vehicle for the Shell eco marathon races. And in those competitions, we go really extreme on the fuel economy and efficiency. Our small vehicle could go 7,700 miles per gallon.
What?
And
what
it's so our fuel efficiency razor could go 7,700 miles per gallon. So
Kelvin.
Yeah, on petrol. So when normal cars can go like 10 miles or something.
Yeah, that's why I was asking you to clarify. 7,700 miles per gallon.
Yeah, 7,700. Yeah.
That sounds ridiculously high.
yeah.
That is my honest feedback.
Yeah, and it's the top 5 most efficient fuel vehicle in the world.
What's the name of this vehicle again?
It's a Shell Eco Marathon competition, and we build the engine and the vehicle ourselves. It says like a small pod with 3 wheels and small driver in it.
Oh, okay.
And the vehicle weighs only like 30 kilos.
Okay.
So
I can really understand now.
Yeah, it's a you can show my Twitter cover picture of it. It's a that vehicle. So there I started to investigate and study where does the energy go in vehicles. It doesn't only go to heat and forward motion. The energy is dissipated in, for example, vibration. And when the vehicle vibrates, it consumes energy. And for example, energy goes everywhere, wasted. So that's where I started to fell in love with energy efficiency in vehicles. Then I changed my my path to electrical and automation engineering, and I started to do robotics, and then I started to travel around the world and be a commission engineer for robotics. And at the moment, I'm in Abu Dhabi commissioning robotics.
And when you say commissioning robotics, what does that mean? Because as an African, commissioning can mean something else altogether for us.
Yeah, I'm like a startup engineer. I flick the power switch on. I try to find the bugs and try to fix all the faults on site.
Oh, okay. So you're the last person to basically authenticate the whole system before it goes live. What kind of robotic systems are we talking about?
Sea container handling systems.
Okay.
So they are fully, they are fully autonomous robots. They need to be very durable, and they run on 12 kilovolts. Okay. So 12,000 volts.
Okay.
So they are very durable and built to the extreme, and that's what I do for my living at the moment.
So all these are from from one company. All these robots you're talking about.
Excuse me, I didn't hear you.
I'm saying that all these robots that you do commission, they are from one particular company, or it's from different companies.
At the moment, I'm working for this sea container robots. So, but previously, I used to work for as a subcontractor for all the export companies for Finland.
Okay.
And I've been a commissioning engineer for rock crushers, waste handling machines, water purifying systems, marine automation commissioning, and all sorts of kind of stuff. So I have a quite broad view of commissioning and startup of automation systems. And I did quite a lot of rock crushers, so I know those were mobile electrical vehicles on track.
Okay. So from
so they had a big diesel engine and or power inlet that you could run them from the grid.
Okay.
Either way.
So in other words, you understand the internal combustion engine systems as applied to heavy equipment.
Yeah. So that's why I'm very surprised that at the moment the zero emissions teams are like very divided. They're not like a unified force against the old oil, because I see the applications where battery electric only cannot work, because, for example, in heavy trucking, there are businesses that will buy thinner windscreens and lighter floor mats for extra price. They will pay extra to get lighter trucks.
Okay.
And I remember that it was around 10% that trucks were running on the maximum legal weight limit. So in those 10% applications, it would make sense to have a light as possible truck.
Okay.
to survive in the competition. So fuel cells can provide a lighter truck than all batteries. So in those cases, it doesn't matter if the fuel cost is higher, because you need to carry a lot of cargo.
Anyway,
for example, if you're just transporting croissants,
that is cake stuff for with the Africans.
If you're just transporting croissants and bread inside the city, or just a beer, you're not on the weight limit. And of course, battery electric truck is the best solution. It's the most easiest and the most cheapest. But if you're hauling, for example, very precious liquids or very heavy cargo, you're very on the limit of the legal weight limit. Then you have to have a very light truck. And at the moment, for example, the best profits where you have where they're really paying extra to have a lightest possible truck are the trucks transporting liquid fuels to
the
harbors. Yeah, they pay extra, for example, to have very light wheels.
Okay, so let me give maybe our listeners a certain context. I think we met through Twitter, EV Twitter, and Antti seemed to have a very different, if I may say, view when it comes to electrification. And because of that, and also because of his background, he seemed to get applications to heavy equipment. So that's why we decided to bring him on the podcast. You seem to imply in your presentation that fuel cell vehicles are ideal for very heavy applications.
Excuse me. Yeah, for example, one application where fuel cells would be really good, or if you have, for example, one harbor where you're transporting those sea containers, you have a lot of cheap energy, and you could just fuel up, for example, the sea container handling equipment from hydrogen.
But you see, the problem with hydrogen, as opposed to battery electric, obviously we are all talking about efficiency. So the higher the efficiency, the better for all of us. But you see, with the hydrogen, we have to generate the hydrogen. That requires energy. Then you have to store it. And
the storage is the most hardest part.
Good. Then you have to distribute it. So the infrastructure, when it comes to the hydrogen systems, has to be built. And because of the way the hydrogen is generated now, of course, there are huge losses compared to the battery electric vehicles.
Yeah, that's very true.
We're talking about
you only need to beat the diesel
cycle.
Yeah.
So
but you only need to beat the diesel.
Yes. So what do you have to say to that? Because clearly, I think we are on agreement that efficiency is king in the 21st century, and the most efficient way we know now is to go electric, be it hydrogen fuel cell or battery electric. So that argument is out of the window. The only discussion now is, should it be hydrogen fuel cell or battery electric, and in which instances are best for each technology?
Yeah, it will be a mix. For example, on the heavy trucks, it will be a mix. In some businesses and some applications, it will be a full battery, and some applications it will be a full hydrogen, and quite a lot of applications will be a hybrid. So you
really?
will, for example, have like when you're building a fuel cell truck, of course you need to first have a electric truck, and you're just applying the range extender, the fuel cell, to it.
Okay.
And you're just decreasing or increasing the amount of batteries in it. Okay. For example, I see, for example, concrete truck, where you have the concrete mixer. They are one of the applications who are running on the legal weight limit. The trucks itself, they change them like every 5 years, but the concrete mixer, they take the concrete mixer out of the truck and install it on the new truck. So the concrete mixer is like
it's used for a longer time.
Reused, and they are like 15 or 20 years old. Okay. So the truck weight needs to be applied to the legal weight limit and also to the concrete mixer.
Good. So if you use the weight of the truck, then it will benefit the entire system.
In those applications, yeah, in for example, those applications, hybrid, where you have a little bit of battery and a little bit of hydrogen. So you can run, you can run the truck without hydrogens. You can drive the tank empty, like 30 minutes, okay, or 15 minutes.
But you see, I have a question. All these applications assume that the current energy density of today's batteries will remain same. All right.
Yeah.
Is it 250 kilowatt hours or so, or 150? I don't know that. I'm not setting the range, but it's between 150 to 250 kilowatt hours. Okay. What about when that figure increases or doubles? That will reduce the waste savings argument. Wouldn't it?
Yeah, but the business model still stays. The business model is still applied that the lighter the truck, the better you are on the business. So the business model doesn't change, even though the battery energy density would triple. You still want a light as possible truck, and if you have, you don't need to have like a large fuel cell. You can have like a small 10-kilo fuel cell on it.
Okay. So let me ask you, how do you think this whole charging infrastructure for hydrogen, how do you see it being financed?
I don't know.
You know, like when you look at this is the argument between the Tesla crowd and Nikola. I'm talking about the companies.
Yeah, the storage.
Because anytime and for me, to be fair, or for the sake of honesty, I think the battery electric crowd are going to win in the end. But be that as it may, I've always wondered, how is that going to be financed? You know, when the world was transitioning from horses to the ICE engine, there was Standard Oil.
Yeah.
A very well-financed and well-resourced company. And others like it, maybe not to the same degree, who were looking for a market for their product. So they had the resource to spend. I hope you get what I'm saying. Now we are talking about one technology that the infrastructure has to a large degree already being built. Of course, it needs to be modernized, but by and large, it has been built. And then we have another technology that the infrastructure has to be built from scratch. And you're talking about trillions of dollars, literally trillions. Where is the money going to come from? Is the oil, oil industry? Is it because here in Africa, when I look at that argument, it is not going to fly. Because already, I'm sure that you are aware that our continent, we have challenges with electricity access. So,
and it's really big on the land.
And it's a huge opportunity. That's what it is. And with solar is going to basically help us solve that problem and escape from the clutches of the political and bureaucratic class. Okay, that are basically doing rent-seeking, engaging in rent-seeking behavior. For a continent like ours, that hydrogen argument will not fly. Who is going to finance it? And when you finance it, who is going to use it? When I can have my own solar panel in my house that generating my own electricity. If we are talking about the heavy construction equipment users, so we're talking about the mines, the commercial scale agricultural farms. All right. Maybe I can see them building their own stations. So as part of the package, the hydrogens, the person selling the vehicle will also sell them the charging. Sorry, I said charging. The hydrogen, the electrolysis equipment. That I can get. But by and large, I don't see it taking. Please say what you're going to say.
Yeah, I think, for example, in the mining and quarries, batteries are going to win. And at the moment, there are already heavy trucks on the mining quarries transporting those rocks up and down, and they are using the regenerative braking on going down the slopes. The storage is the problem in the hydrogen. Steel tanks are dangerous, and carbon fiber tanks are also dangerous. And I think the best and safest solution where to store hydrogen is glass fiber tanks.
Really?
When you have a steel tank or a metal tank, it can when you have rupture failure inside the fire, it's gonna go off like a bomb. Yeah,
it's a bomb.
Yeah, but if it's carbon fiber or glass fiber, it's gonna melt and release the hydrogen very in a safe way, less dangerous way.
I don't think the difference between the two scenarios you are painting is, in one, you have projectiles that can cause physical trauma. In the other instance, they are not projectiles. But we're still talking about a lot of compressed air and heat that is leaving a certain point at high velocity. That in itself is very dangerous.
Yeah.
And another question I keep wondering about is the cooling problem. Because basically I'm going to store the hydrogen in compressed format, right?
Yeah. There's a lot of problems in both, and especially in the fuel cell. I think there's still so many problems to be solved on fuel cell, but we still I think we need both batteries and fuel cells.
But the fuel cells problem.
But yeah, as I was.
Are they being solved? Have they been solved? Have they been solved? That's my major concern.
Yeah. As I was let me tell you more about the storage problem.
Okay.
As I am very familiar with carbon fiber and glass fiber.
Okay.
So when you have a carbon fiber failure and you have that dust from the carbon fiber, it's like carcinogenic on the lungs, so you should not breathe it.
Oh.
It's like asbestos. The carbon fiber is safe until you mix it with very brittle plastics, and when you handle like the pure carbon fiber, it's okay, and when you cut it, it's okay, and if you have the dust from cutting carbon fiber, it's okay. But when you mix it in the plastic, which is usually epoxy,
Okay.
it becomes very stiff, those dust particles, and when they go in your lung, they stick in the lungs and they will never go out. So it's
wow.
It acts exactly like asbestos.
That's very
so
dangerous.
carbon fiber tanks are not safe in the long run. Yeah. So but it doesn't matter because the glass fiber tanks are not that heavier. So a glass fiber, when you have a like a physical shrapnel in the tank, or you throw it on the fire and you have hydrogen in it, it will fail in a safe way, but it will slowly erupt, and not fast like when you have steel tank. It will slowly erupt and open up, and the gases will exit, and it will not explode. But you will have a big fireball, but it will not explode. So that is one thing to keep an eye on. This is not widely spoken knowledge, because the carbon fiber industry doesn't like to present this knowledge. But if you research on this, you will find, for example, that if you have a plane crash, when you have the high-end carbon fiber, you need to have like a space suit when you go to the crash site, because you have that dust in there.
Wow.
I used to work in the composite industry, so I also know this.
That's very discouraging. And
So
I can bet you
but
that if Africans hear about this, that will be the end of it. So nobody will want the technology.
yeah, but the glass fiber tanks, they are. I researched those different YouTube videos when they have a failure with the composite tank, and all of those failure methods, it looked safe. When you have like you shoot the tank while it's on fire pit, it's okay. It just it doesn't explode. But if you have a steel tank, it will explode. So, but if you have like put it on fire and don't do anything and wait, it will start melt, and it will start open and throw out the gases, but it not explode. So that, in a sense, changed my view of the fuel cells, because I think we can solve the storage problem in the long run with composite tanks. And we can also make those composites from biomaterials, because glass fiber, it is a stone. It's rocks, it's glass.
Okay.
and you can use the bioplastics on it. So you're using plants, leaves, and like, for example, wood on the bioplastic, on the binder. So it will be stones and leaves. The construction materials.
I still, from what you are telling me, basically, it means that the problems have not yet been solved. They are now working on it. And by
Yeah.
the time they solve those problems, the battery electric technology
Yes, they will be
have
really far
improved
ahead.
dramatically. So it may be too late.
Yeah.
It's like the VHS and Betamax scenario all over again.
Yeah.
Because the technology is able to
Yeah.
reach mass market, will dominate.
Yeah, fuel cells are never gonna hit mass market. It's gonna be a really niche market.
Okay.
I see that. So I think passenger cars will never be fuel cells, and also very niche market from the heavy trucks.
Okay.
And so it's not gonna be the mass market fuel. That's my view also, because the batteries are going so far ahead, so fast.
Okay. I think let's talk about EVs and Tesla, battery electric vehicles and Tesla. I think the initial exchange that we had,
Yeah.
or what I get is, you have the feeling that there is some people who support Tesla have formed like a cult. So it's like it is us against the world. So even if it's an EV, another EV, so far it's not a Tesla, they have a way of maybe looking down or talking down on it. Can you sort of clarify your thinking along those lines for us?
Yeah, I support Tesla, of course, and I'm a fan of Tesla.
Okay.
So I didn't hear you well on your question, but Tesla at the moment is the leader, and it will stay as so for a very long time. And I hope them all the best. And at the moment, I don't own electric vehicle myself, but possibly in near future, when I stop this travel work, I will buy a Tesla, of course.
Why when you stop? Why not now?
Because I've been traveling for 4 years.
Okay.
So I need to stay in my home country sometimes.
Oh, okay.
So
I get it.
at the moment, I don't even use my car. It's I took it off the registration.
Oh, that's serious.
But yeah, the Tesla is a really interesting case, because they are building also the electrical grid. They're building the solar. They're building the power balls for
It's an entire
personal use,
energy ecosystem.
and they are yes, and they are also building those small large mega packs to correct the imbalances out of the grid from Australia, for example, and they will just increase that production, and they are making the battery production more eco-friendly and more cheaper.
I just saw a tweet.
And they are
Please continue.
yeah. But at the moment, I don't see Tesla still going in the same market as Caterpillar and John Deere.
That is the challenge, because it seems like Tesla is because of Elon Musk. It's like they want to be seen to be high performance consumer vehicles.
Yeah.
But in a lot of places, and that's fine. But the
Yeah, it
market,
is.
generally speaking, you see, like in Africa, for example, 80% of the population don't use private cars. We use the mini buses and this work van kind of form factor buses to transport our population. Okay, we need a lot of farm equipment. We need construction equipment because we are developing nation. We need to that we have a lot of infrastructure to build. We are a resource-rich continent, so we need a lot of construction equipment. If you are using an electric dump truck or whatever for mining,
Yes.
it is going to decrease your costs.
Yeah.
On so many levels, because if you are digging underground, you're using diesel equipment. It means that you must put up infrastructure for extracting the exhaust gases. But with electric, there's no gases to make provision for. All those costs evaporate. But I don't see
we need to make
a hint of a thought from Tesla for such problems.
Yeah, they're not gonna go to that market because they're not experts on it. Caterpillar and John Deere, and for example, we need to make it cheaper to use electric vehicles. I mean, electric tractors and bulldozers, also in the Western countries, than the diesel. So they will eventually hit all around the world with those electric powertrains.
But are they doing it? I don't see a lot of seriousness when it comes to the John Deere's, the Komachus, in terms of electrification. I know that Komachu, for example, they have done some small backhoe or something of that nature. But you don't hear of serious plans of making electric.
No, and
why?
And I'm very disappointed on that. One is that they are their specialties are in the hydraulics and also in the mechanical engineering of the steel and casting frames.
Okay.
They are
basically
not
hydraulics
in
and
the
metallurgical companies.
Yeah, they are not for example, if we take New Holland or Massey Ferguson, they don't make their diesel engines by themselves. Those diesel engines are manufactured in Finland. So they are from the Akko group, and the Akko group consolidates all their diesel engine production to one company, to one manufacturing plant, and they distribute all the engines to Fendt, Massey Ferguson, and New Holland uses. New Holland is not a Akko group. I don't remember anymore. but
this
New Holland is kind of New Holland industry.
This makes it easier for them because you know that that's not your expertise. So just get the skateboard from somebody who can do the power electronics and maybe the batteries, and just put it in a shell. Design a shell from the ground up around the EV platform. So you are not maybe a VW that you have a strong, your core competency is in the internal combustion engine. So we don't lose either way. But still, I don't see any attempt. It's that they are just there. It seems that so long as they are making their revenue, they are okay. And they are making the same mistake that the VWs, the Toyotas made. Somebody will come with a powertrain based on
exactly.
and come and disrupt them,
for example,
and make them irrelevant.
One company that I know that makes powertrains for heavy diesel machines. they are making hybrid forest harvesters.
Okay.
It's called Danfoss Editron. It's a company founded 2012. They
young.
made first. It's a Danfoss Editron. The company name first was Visedo,
Okay.
and at the moment they are making powertrains, electric powertrains.
Okay.
They at the moment they just use the customer diesel engine, and they have the big generator bolted to the diesel engine. So the powertrain starts from the generator, and they have the frequency converter and small battery unit, and also the big motors to the wheels.
Okay.
And they are making powertrains, for example, for forest harvesters and wheel loaders, and they just finished one super yacht with electric powertrain, and they also have applied that their powertrain to one water dam, where they're generating electricity from the water.
Okay. And are they getting customers to pick the powertrains to do the equipment around?
Yeah, and I think I'm still wondering why are they not getting any sales?
Because the people, you see, what you have described is they are doing the powertrain, so the powertrain is supposed to feed into somebody's final product. So if the person who will use the thing for the final product is not ready to produce, obviously they will not have sales. And that is the challenge I have. Because if I ask you right now, okay, when do you think, how long do you think it will take for 2% of heavy construction to be electric, be it fuel cell or battery electric? How long do you think it will take, or which year?
I don't know. I hope it will be fast, but at the moment I'm really pessimistic.
Yes, it is because the people who are there currently are not interested. Maybe you should consider doing something like that, a startup for that, because you see, another thing I think nobody's, when I talk to people in the Western world, they don't seem to realize that in a few years' time, in a couple of decades, Africa is going to be the youngest and the biggest continent in terms of population. Okay.
Yeah.
And we are still urbanizing.
One problem. Yeah, I think one problem in the sales of electric powertrains is that the machine is completely different when you're applying that electric powertrain, when you are replacing the mechanical gearbox from it.
Okay.
For example, if you previously had to use like a 300 horsepower diesel engine,
Okay.
and you apply a electric powertrain to it, not only your efficiency goes up, but also your power demand goes down, because you can suck the required power from the motors and from the small battery instantly. And usually you don't need to have so much power constantly. So you can only use like instead of the 300 horsepower motor,
Okay.
you can use, for example, 75 horsepower diesel engine. So the change is so radical in there.
Wait, I didn't get that clearly. You are saying that with the diesel engine, for example, maybe we need 75 kilowatts, but for the electric motor, you need like 300 kilowatts. How does that work?
Yeah, if you
Because we know that the electric
if you put
is more, the electric motor is more
electric power
efficient. It's more efficient. And in terms of control, you can get the full torque or power from 0 to the ceiling, and you can even regulate it to a better degree. So why should you need more power?
I mean, you need a way smaller diesel engine if you're making at the moment those hybrid wheel loaders, for example, in the construction site.
Okay.
So I'm explaining this because I think this is the reason why these electric powertrains are not so common yet, because this you need to change your thinking so much, and you're designing so much.
Okay.
So if you have the wheel loader, if you have the like a 15-ton wheel loader, and you have a 300 horsepower diesel engine on it, you put on the electrical powertrain on it. You only need after that the 75 horsepower diesel engine on it, and also you can reduce all other components in there, so it will be cheaper on the day zero to the customer. It will be cheaper to manufacture with electric powertrain.
Good.
Because you can reduce the size of all the other components too.
Good.
But
so the customer
this is really radical. It's really radical thinking, and it's not the usual way you think when you're applying electric powertrains to tractors, for example. That you can make a small tractor, but it will be capable of doing the same things. And best example of this will be the excavators, because in excavators you have only two criteria. You have the length of the boom, and also the Newton meters that you can pull the ground, and also the weight that you have the counterbalance.
Okay.
And if you can make the power from the electrical motors to the hydraulics so stable that you can make the excavator cheaper if you use this Dynaphos electric powertrain, for example, on excavator.
Which means that to the end customer, it is a more affordable solution.
Yes. Yeah.
But the manufacturer
with the same
results,
capabilities.
Yes, but the manufacturer, he needs to reorganize his whole mindset, and I suppose the entire business model and organizational structure, which is difficult. Is that not so?
Yeah,
and they want to avoid that. That is why they are not doing it.
Yeah, this is you can already see this change when you're using these diesel hybrid powertrains, and the change to going to full battery, it's so small after that. You just need to throw out the diesel engine and also the tank, and apply and put in a little bit larger battery, and also the charging plug.
I have a feeling that maybe the manufacturers also make a lot of money from the maintenance and the spare parts for the.
Yeah, that is very true. Very true.
Because that would then explain why they are reluctant.
Yes, that is very big reason, unfortunately.
But
I used to be in the service business also, so I know that it's a
cash cow.
But it's unnecessary fear, because you still need to service them. In the service industry, you don't service so much the diesel engine on excavator. you need to service with the wheel tracks, the hydraulics, the steel parts on the frame.
Then did I have a problem?
And so the diesel engine didn't need that much of service. So the service business will not die. You still need the right incentivized service people. And one problem, of course, is to train those service engineers and service technicians for the new powertrains. Because these electrical powertrains, if you apply, for example, fuel cell and battery electric hybrid, it's gonna be so complex that, like, it's incredible how complex they will be.
Okay.
And that's also one problem. Even though they are cheap to manufacture, but they are very complex to service.
Really? Why is that?
They will. There's a lot of electronics and electricity in there. You need to have a different kind of mindset and tool set, and different equipment and different handling procedures. Because previously you didn't need to be careful of the electric shock, for example. The only electric shock that you need to be careful were from the 12-volt battery, and it was easy to take out the cord from the battery. But when you have electric powertrains, you're constantly in the fear that you will have electric shock. Not in the best case scenario when you have the equipment will have its scheduled maintenance, but in those scenarios when you have like accident or it will be hit by something, and there are wires hanging everywhere, then it's for example quite a bit dangerous.
Okay.
And you know this happens.
But,
of course, when you roll over. So that's one scenario. For example, you just need to train it, and we have seen already from the Tesla service network that these are all problems that we can solve.
Yes, that's what I was going to say, especially for heavy industry, because you are already used to building equipment for abuse.
Yeah.
So
yes.
You try to build as much as possible for simplicity and for robustness.
Yes. And Tesla has shown us so many examples that all the problems that we thought that would be really hard to solve, for example, the service of the electric powertrains. It is easy if you just train the people. And the training, it's not that complex in the end, but you just need to do it. You also need electric insulated tools, for example, electric insulated screwdrivers, and but they don't cost that much more.
Anyway, as an African, I'm interested in, like I said, I'm interested in this because of construction, because of mining, and because of farming, agriculture. Antti, I will not take much more of your time. Thank you very much for giving us this opportunity to interact with us. We will definitely invite you again, most likely for a panel discussion. I mean, it was just unfortunate that Olukokun is not here. He's a mechatronics engineer, so I know that he will be excited to have a discussion with someone like you.
I was excited to do that, to have a discussion with someone who wants to see the zero emissions world.